Yeah, as I said, I'm sharing my recordings on my blog and a bit of a recap. What did we look into last time? Carrying, yeah, something that's quite specific to the functional programming world. So if you're coming from JavaScript or Ruby or Java, then you're probably not super familiar with this principle, but it comes in very handy often. But I'm not going to talk about this again today. What I want to look at today, like last week, we managed to get our tiles moving in a way that we cannot move them outside of the screen or have them like move into each other. So that's great. And it actually enabled, like we're in a good position where we can actually form whole rows. So that's something that is nice, but it is obviously lacking the satisfaction of those rows actually vanishing. So that's something I want to look into today. Yeah, so let's jump right in. As always, I have my build script running here in one shell already, and in the second one I open my editor. Why do I have already a session running? Yeah, because I had this temporary window open here. So let's quickly shut this, close this, queue, and now it's happy again. So yeah, let's think a bit about when should these rows vanish? When do we have to check for those conditions? And I would argue it's basically at the same time when we spawn a new piece, like when we cannot drop the current piece any further, then before spawning a new piece, we can directly check if we can remove any full lines that the piece formed on the board, and just remove them. So I'm not going to think about too much about an animation for this row to disappear just yet. Like I blissfully accept the fact that if I just remove this row from the board, it would just vanish in an instant. And while this is obviously not super pretty, we'll just work our way up or down from that state once we arrive there. So let's see again. What was the place the function called? I think it was move piece. When we press key down, no, that's actually not the one. Move piece. Can drop was something that is probably a good function. Let's see where this is called. This is called from the drop current piece function, yeah, which is basically logically ties to, or technically ties to, the logic moment that I described. When we cannot drop the piece anymore, then if we cannot drop the piece, then we end up in this else branch here, and we calculate the new board when we bake in the current piece. Place current piece on board, exactly, and then issue the command to generate a new piece. So I guess what we can do, we can just update our place piece on board function to, no, I think I want to do a second function. Let's call that function erase complete rows. And I would say it takes a board and it returns the board. And I think that's such a nice, pure, I mean, all functions are pure in Elm, but it's such a function that nicely encapsulates some really essential logic of the game. So I feel motivated today to write a few tests or develop this a bit more test driven again. So let's open our test suite that, to my dismay, is still called example.elm, but we'll worry about this another day. So I'll just grab one test from our existing suite. Can drop. Can I actually nest this a bit nicer? Ugh, I'm too lazy. Can drop. Am I too lazy? I feeling really lazy about this. No, I'm not really. I will look how to proper Elm test, how to properly nest some describe blocks. Elm test moved. That's probably here. Yeah, so we can just have a describe blocks that again has a list of, oh yeah, okay, cool. So let's, our top level, make a new top level describe block actually. Let's call it describe Tetris. And then we'll just pass in all of that as a new array. I kill my build script for now and just call Elm test -- watch instead, because it will automatically compile if necessary. Test ran, I haven't saved yet, so now I will save this, and it's still running or passing, so that's awesome. And now I can grab one of those existing test or describe blocks here. Boom. Describe, what did we call a new function? What did I call it? Erase complete rows. So let's just copy that. Boom. Yeah. What's our first test going to be is erase full row. Change erases full row on bottom, let's say. Cool. I think we have to fix some brackets here. So the test is not making sense, obviously, because it's still a copy. I just want to make sure I have everything indented correctly, so that's good. I think we are going to do a little. Do we have already in test that places something already placed? Board with a tile, that looks also good. What piece already placed? Yeah, okay, that's good. That's some helpful stuff. I'll just grab this here to set up our test. So we'll make it really simple. The tiles will be basically just a bar, a horizontal bar that covers the whole row, so that we only have to place one tile, and then this row should be cleared. So I'm copying this tuple here, pasting, and put one piece to the left, yank to closing bracket, jump to closing bracket, and one tile to the right. Position is, row is all the way to the bottom, and center column is also good. So and I had this neat string representation, did I not? No, I didn't. I don't know which project that was in, but it was not here apparently. Okay, no matter what. So we have an empty board, we have an already placed tile, we have a board with a tile. So now we want to call our new function that I called erase. Yes, that's the one. Board with a tile. And how do we make sure, how do we compare with, how do we specify our expected result? I think we can just write out the rows, I think. How did we define our rows? And maybe we just make this compile again as well. Just not doing anything yet with the board. No, I don't want to enable dictation, thank you. Yeah, let's see how we define the rows. Type row. Oh yeah, it's a. So let's just copy this over. Let's create an array expected rows equals, just to see, boom, 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 list of fields. What is, or let's create an empty row here. Make empty row. What does make empty row? We can use this. Make empty row column count. Okay, cool. Empty row equals a make empty row 3 0. It's ignored anyway. And then we can say, and what does it return? A row? Yeah, so we can just say empty row, empty row, empty row. So recap of our test. Now let's expected rows. It's not completely done yet. So here we can say rows. So my assertion here is, or what I'm testing is, that after we erase complete rows from our board with a tile, which is the empty 3x3 board, where we place a piece that is in the bottom row in the center and extends one to the left and one to the right, and I'm missing a closing bracket there. So if we take this board with it, which has this piece that is spanning the whole board on the bottom, and we call erase complete rows on that, then we expect the rows on the resulting board to equal the expected rows, and the expected rows are 3 empty rows of the width 3. So let's save all this and see where I messed up. Okay, cool. So like, since we actually did not implement, or since I didn't implement anything here for, where's my erase function? I'm just returning the board. That's exactly what I was expecting. The row 0, which is the bottom row, the first row in our array, is a row with 3 red fields. And our erase function is supposed to remove those. So let's start out by doing this. So yeah, let's make a little local function that's called replace with empty if full. Okay, and that takes a row. Or we can already say a row of fields, and we don't have to destruct it later. And we say if full is defined by if all fields in this row are not empty. I don't know if I already have a function for something like this. Row view, something, a predicate that tells me if a row is empty. No, so I'll just quickly write a new one. So let's call it is full. Takes again a row of fields. And I believe we already... So the question is, how do we logically express it? If all are not empty, or is... No, if all are not empty, or is if any is empty. Those are the two logical sides to use this one from. And I would say, I feel if any is if any is not empty, or if all are not empty. I don't know. I have a trouble deciding tonight. We already have all imported here. Let's go with all. All. And I create a little anonymous function here for the predicate for the field. If all f is not equal, empty on fields. Cool. So now we can say if, I'm just going to give this parameter also an alias as a whole called row. If is full row, then we can just create an empty row. That is because that is always the same. We don't have to create new empty rows over and over again. So the empty row is a make empty row board width 0. I'm not super happy about this weird dangling 0, but I know this empty row function, make empty row function, expects the second parameter that gets consequently ignored, so I just stick with that right now. So if the row is full, then if the row is full, then we can just return the empty row. The empty row. Otherwise, well, actually, yeah. Otherwise, we just return the row itself. So actually, this whole shebang up here is unnecessary. We can just call a row. Cool. If full, replace with empty. And now we can just say board. We update our incoming board, and we update the rows, and we map over the rows with the replace empty if full function, and we pass in the original rows. Cool. At least it formats, so that's one thing I got right. And now, yes, well, we got a empty row that has a lot more empty rows than a... yeah, okay, I got it. That is a mistake, beginner mistake. I used this hard-coded board with value. That's really not good. So I would, in fact, do have to construct an empty row from the width of the input row, basically, or the board that we are working on. The empty row, or maybe, yeah, we can do a little optimization later tonight if we if I accomplish everything I want to accomplish before time. 20 minutes in, looks so good. So let's create a new empty row. Make empty row, and we take the length of the row. And we throw away this part of the approach. Row. Yeah, row. Okay. So now we do have to introduce this thing that I anticipated and then didn't use. Row, fields as row. I think we have to give some parentheses here to help parsing. Compilation failed. Length row. Yes, I also have to use the fields here. Yippee! First test is working. Cool. So that's good. Now, second thing we need is that the rows that are above the cleared or erased rows actually drop down. So let's write a test for this right away, because I'm pretty sure this does not work yet. So our test setup for that has to be a bit more intricate. So let's put a let's call it dropped piece. Dropped piece is good. We put it above the line that we're clearing. We make it a bit easier for ourselves by just making it one tile. We are coloring it blue, so it's a bit more clear what we're expecting to happen. And we have to place it as well. So board with row to clear is this one, and board with tile to drop. Oops. Drop is place piece on board, dropped piece, and we place it on the board with row to clear. So now we have a board that has the red bar all across, still on the bottom row, and in the center of the line above there's one blue tile. So then when we erase the red bar on the bottom, the blue piece has to drop into the bottom row. So let's update our expectation here. Expected rows. Let's add some break lines. And the bottom row, which counterintuitively in our array presentation is the top, but it's the row 0. That's why it's the row with the index 0. That's why it's on in the front in this array. Here we want to have a row with 3 fields. The left one will be empty, the center one will be field blue, and the right one will be empty. So does this compile? Board with a tile does. Also we have to call the board with a tile to drop. Board with a tile to drop here. Okay, I think this is a typo. This name seems closed. There's always a sign for that has something happened due to my poor typing skills. So I'll just use autocomplete here. I cannot find a board with a tile to drop variable. Why not? It's right there. No, it's not. Why is it board with a tile to drop? Because I have a similarly named variable already somewhere else. Okay. Yes. The tests container. Okay. I have to rename the test. Erase drops rows above cleared rows. Delete the rest of the schmuck. Cool. So what happened here? Expect this, but it is this. Actually, I'm not sure. I think I also have to. This piece, or this tile of the piece that we dropped should also be in the center. And now that's more aligned with what I expected. The bottom row is empty, but the blue field is still hovering, so to say, in the middle line. So let's try to fix this. So how do we think of this algorithmically? So we successfully cleared the lines, but now we have empty lines there. So that's also not really correct. So basically we want to remove those lines or these rows entirely and then top up the head of the board with fresh empty rows. So I think that's a good way to do this. So basically we want to run once through the list of rows, remove the ones that are full, and count how many lines we have removed. And I think this is a good opportunity to toy around a bit with folding, because now, like, we cannot use basically the result, well, the end result is a list with the same length, but the intermediate result is when we just remove the full lines, excuse me, is a list with a different number of rows. And anytime that we process a list in a way that we don't end up with the exact same number of elements, we cannot use map. That's like, for example, if we have a list of numbers and we want to calculate the sum, then we put in, I don't know, 10 numbers and end up with one number. And that's why it's called folding, because we are reducing the original cardinality of this to something else. So I'm still not decided how I approach this. Like we could turn the list of rows into a list of maybe rows, where we turn the rows that are full into nothings and then use the values function from maybe extra that just takes a list of maybe somethings and just extracts the somethings and throws away the maybe container around this. That's one way. Yeah, actually maybe we do this and then we don't have to use explicitly fold, which is not too bad, because fold also always adds quite a bit of cognitive load to figure out what's going on inside the folding function. So I don't know, but then how do we find out the number of... yeah, no, let's do this. So replace with nothing. If, well, maybe that's a good approach. So my idea is we transform the list of rows into a list of maybe rows. We transform the empty rows into nothings, and then we take the just rows to calculate the bottom of the field of the board, and then we count the nothings to find out how many empty rows we have to add on top. I think I like this. So or do I like this? Do I like this or no? I want to fold, because otherwise we have to run over this temporary array over and over again, and I just want to do it in one run. And I want to have to go through folding it, because I feel I will struggle a bit, but I also know that once I work through the problem with the fold, I will be happy with myself. So it's on fold. So instead of, let's see, do we do this? Yeah, we assign the initial expression here to something else. Let's call it new rows. And assign the rows to new rows. So maybe, yeah, like I'll just, whoops. I don't know, have I used fold here before in this program? Fold? No, I have not. So it's a great opportunity to showcase this. Fold, let's use the fold R function. I quickly add it to my import because I already know that, otherwise it will complain. Fold R. And yeah, I can show you quickly how I like to approach writing my fold expressions. So I know still that I want to fold over the existing list or array of rows. Well, I should really say list because that's what it is. And fold takes 2 more parameters before I can pass in the board of the rows or the collection I'm folding over. And the first thing is the folding function. I just call it f here because I think once I start writing it out, a good name for what it actually does will come to me, a better one than f, and no need to bother right away. And this other parameter here is the starting value for our folding operation. So if we fold integers to calculate the sum, for example, then each time we call the folding function, we want to add something to our accumulator, but our accumulator has to start out with something. So in the sum example for folding, this will be the number 0. But here, well, we want to end up with 2 things. So maybe it's actually a good exercise to start to write out our starting value, because we want to end up with two things. One is the bottom block of the non-empty rows that have not been removed. So this will be an array that we will start building up while we iterate over the rows. And the other thing is the number of empty rows we have to add at the top. Or we can actually say we can build up the top right away while we're folding. So maybe, and then we will take this header basically for the new board, and we will just prepend it to the rows that have not been erased. So let's say it will be an array as well, because the good thing now is we know the signature for our folding function, or let's call it the folder. The signature for the folder function is now implicitly defined by where's my mouse cursor? By the accumulator value and the collection that we are iterating over. We can quickly bring up the Elm list fold. Boom. We can bring up the documentation for fold R. Oh, that's the wrong one. I mean, the signature is very similar, but let's just jump. So the fold R function reduces a list from the right, and it takes, like, maybe we work our way back from the parameters, because this way it's a bit easier to understand. It takes a list of A and it produces a B in the end. So whatever parameter we put as our starting value will also be our return value. And since we have already defined our B, like, maybe we just copy over this declaration, because then we can write up our definition for folder. And the nice thing is actually something, I got another helpful tip on Twitter today, is that we can also write signatures for functions that we define in let blocks. So let's do this right away. So our folder is this function, from A to a B to another B. So we just have to fill in the blanks or placeholders here. So I said whatever is coming, or whatever we pass in as our initializer value here, that's the B. And this is a tuple of list of rows and list of rows. But actually the first parameter for our folder function is not the B, but is the A. And the A is defined by the list of A's that we pass in here, so our board rows. So it's a list of row. So our A is actually a row. So the first parameter for our folding function is a row. The second parameter for our folding function is the B, which is the tuple of rows. So it's list row. And the return value is a b again, so it's the same tuple. So it's again list row. Okay, cool. So let's give those parameters some names. Or we can just say row, destructure this into the fields directly, because we probably, do we want to do something with this? I don't know. No, maybe I'm jumping ahead here. That's getting ahead of myself. Let's just call it row, and non-empty rows, let's call it this, non-empty rows, and the header that we're building up. Okay, so now we can reuse our predicate that we just built in the previous iterations. So if is full, and I have to pass in the row as well. So if the current row is full, then we want to return a tuple where we keep the non-empty rows just as they were, but we append an empty row, make empty row, length. Yeah, now I do need the fields. Make empty row fields. Oh, actually, do we have the width information in our board type yet? Type ADS board. No, our board is just a plain list of rows, so we have to derive the width of the board from the length of the current row. So no shortcuts here. Make empty row. So now we have created. Oh, maybe we can even. No, I'll just stick with this. It's not super readable. There's definitely some room for improvement for readability, but I can, at least for our tuple, I can break it into a new line. So the first value of our tuple is the list of non-cleared rows, and the second is a new empty row that we prepend to the header that we have accumulated so far. Okay, that was the case for when we are iterating in our fold over the list of rows and we hit a full row, then we prepend an empty row to our accumulating header. Else, so let's copy that expression and adapt it. If the row is not empty, then we prepend this row to the list of non-empty rows, and we do not change the header. Cool, so now we have our folder function. Can remove this signature here that I just brought in for explaining, deriving, whatever. We are folding with our folder. This is our starting value, and those are new rows. And our new rows now, this, as I said, like the return value of the fold has the same type as this starting expression. So let's say final header, and let's call this the I know already that it will complain if I call it non-empty rows as well, because it's it will shadow this local variable, so I have to come up with something artificially different, more clear. All non-empty rows, and the new rows are the final header plus all non-empty rows. Awesome. Let's see how many mistakes I made. 405, some syntax mix up. Make empty row. Ah, yeah, it's missing this. parameter that I always forget. Also the cons operator, so the one that prepends an item to an existing list, is 2 colons. And the same here, and it's a bit confusing because in Haskell that has a very similar syntax. The double colon is used for in function signatures, and the single colon, so it's exactly this other way around basically. So and now it's complaining about the absence of fields, which is correct because I have to say row fields as row. Whoops. Involuntary indentation. And woo, it's compiling. So, what's happening? We expect our blue field to be in the center of the bottom row. But it is still not there. So that's interesting. Do we use our new rows? New rows. Okay, I'm curious if our final header contains any empty rows. So what's yeah, all kinds of things. It just looks as it didn't do anything at all as folding. So let's debug log the final header, and I fear this is empty. Yeah, I should not write type while talking. Final header, I fear this. Let's see, final head. No, final head is actually one empty row, so that is good. But I'm actually the way our rows are sorted is actually more confusing than I thought, and I'm kind of wondering if that was a good decision. But I have to append instead of prepend our header because the top rows are at the end of the array of rows. So fall, okay, that's where my F went that I just had to add. And now it's working, so that's great. So let's do some final test where we make sure that if we have 2 rows at the bottom and the blue single tile on the top, that 2 rows are clear and the blue tile drops all the way to the bottom. Not sure, I'm not trusting my own logic here. I just have a feeling I might have missed a corner case. So that's the stuff that I want to copy. I have to change this into a comma. Drops above multiple already placed. So, we just say the other already placed type piece is, and we just make use of the fact that the already placed piece has already nearly all the good things. We'll just assign it a new position in row 1. That reminds me that I want to put that piece into row 2. Add my closing bracket here and paste what with row to clear with 2 rows to clear is we take the other already placed, we take the board where we already bought what is what with row to clear, and then the drop piece we have to place on the board with 2 rows to clear. And I'm also fully aware that this is getting also a bit out of hand here, the length of the test description, and this can be written much more elegantly, but like we are on a mission to an MVP here, and like also we know like once it compiles and it's working, then it's much easier to refactor than trying to do everything at once. So let's make sure our test is good, like the expected rows in the end are still the same. We just have, and the call is actually all good already. So let's see if that works. Position, a little typo here, postillon, position, boom, and it works. So that's great. Okay, cool. So I'm pretty happy with this. We now have a function that takes a board and removes the full lines. So now everything, all we have to do is, after we place a piece on the board, we just have to call this function on the resulting board. So without further ado, erase complete rows, boom, pass in what we've calculated before, recompile, refresh. Okay, now you have to go through the painful experience of watching me play Tetris until we have a full line. But isn't that lucky? Yes, success! Isn't that beautiful? Isn't that beautiful? That doesn't happen too often in real life programming, right? That you execute it and it works on the first attempt. That's the beauty of functional programming combined with test-driven development. So that's cool. And I know I said I would optimize something. Yeah, I remember again this make empty function. So I was bothered, or I'm still bothered by the fact that we're creating empty rows. How many times? Where did it go? Folder. I mean, it's only in one place, but basically every time we clear an empty row, we clear full row, we replace it with a new empty row, like really fresh in the freshest sense, that we are mapping over a range, so we are creating new objects. So that's not really cool, because I would argue once we create our board, all empty lines will look exactly the same and we can just reuse the same object instance. So let's try to create a little optimization for this. I don't know, actually, maybe I'm also lying. I will just No, I will not prove my point. I don't know, like theoretically Elm could optimize this call, like it just could know that since it's a pure function, that it had already been called with these two numbers, 0, 0 or whatever, or 5, 0, and it doesn't have to recompute this. I'm actually not sure. I'm not sure if Elm makes these kind of optimizations. I'd be really curious. So if anybody who knows more about these optimizations that Elm is doing is watching this, please tweet or let me know in a comment on my blog or whatever. I'm really curious. Or maybe I post this question later on the Elm Discord discourse. Yeah, this board thingy. But anyway, I know how we can make sure that the empty row is only computed once, and that's by baking the empty row into the board itself. So let's go to our type declaration for the board, alias board, where are you? And we put another property here and call it empty row. And this will be a row. Unsurprisingly, I will just save this to let the compiler know where I'm making it unhappy with this. Line 188. Here is where we create our board. So, whoops, empty board. Where did you come from? From make empty board. And make empty board takes the number of rows and the number of columns. So empty row equals, let's create a local expression here that we also call empty row. Let in empty row equals make empty row columns. Yeah, I'll just copy this expression for now and append the dreaded what is it, probably like the row number that's not used. And I guess we can also then simplify this expression into a function that takes the row number that I don't need and returns the empty row. So this should still work. Compiled without errors. This seems to behave rather normally as well, so that's great. And now, do we have an isEmpty function? No, only for particular fields. But now we can revisit our erase complete rows function, and we can remove this make empty row because we can just replace it with a reference to the empty row on our board. So does it still work? Yes. I mean, we have to actually wait for the row to vanish to confirm this theory, but I have a good feeling about this. And the good news is we are not mapping over this range anymore. Each time we replace a full rows, thousands, if not 100,000s of cycles have been saved by doing so. Here we go. Boom! Still works. So that's awesome. How much time? Yeah, like we are 5 minutes short of the full hour. So I think that's a good opportunity to make a cut here. As I mentioned, somewhat unsatisfying is the fact that these rows vanish without any animation. So that's not super cool. So I think this might be something I look into next week. I will try to whip up some an episode recap on my blog and put out a tweet once I have done so. But yeah, thanks again for staying with me, and hopefully see you next time.